Hey guys, Mrs. Lansford here. So I'm going to walk through the 7.6 Part 2 notes with you, which is more solving trig equations, but with the new identities that we just learned in 7.6 Part 1. So, review, solve the following over the domain 0 to 2 pi. So number 1 and number 2 should look very familiar to you. We've been doing a lot of these over the last couple of sections. Strategy number 1, factor and apply the ZPP. If you don't remember what the ZPP means, zero product property. So something like number 1, when you see 2 sine squared x plus sine x minus 1, you should be able to factor this at this point into 2 sine x minus 1 sine x plus 1 equals 0. By the ZPP, either the first thing equals 0 or the second thing equals 0, meaning that we have either sine x equals 1/2 or sine x equals -1. At this point, I always draw kind of my unit axes and think about in which quadrants is this true. Well, sine is positive in quadrant 1 and quadrant 2. So my general solution is pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. Sine x equaling -1 happens only once on my unit circle at 3 pi over 2 plus 2 pi n. It's only asking on the domain 0 to 2 pi, so I give my final answer as just my 3 from the unit circle, pi over 6, 5 pi over 6, and 3 pi over 2 in set kind of notation, if you will, or the set of solutions. So looking at number 2, it says factor by grouping. So here I have 2 tan x cosine x plus 2 cosine x equals tan x plus 1. First thing I always want to do when I'm factoring is get everything to one side. So 2 tangent x cosine x plus 2 cosine x minus tangent x minus 1 is equal to 0. And this says I'm going to factor by grouping, which is a nice kind of hint. And then I want to look at these two terms together and those two terms together. And if I notice from that first set of parentheses, I can pull out a 2 cosine x. And I am left with tangent x plus 1. And if you notice for that second set of parentheses, I can factor out a -1, and I'm left with tangent x plus 1 equals 0. Exactly how I would for factor by grouping in Algebra 1, except with a little bit of trig sprinkled in. So now this factors into 2 cosine x minus 1 tangent x plus 1 equals 0. Again, ZPP, either the first thing equals 0 or the second thing. So from this one, cosine x equals 1/2 or tangent x equals -1. I always draw my unit axes for both of these. Cosine is positive in quadrants 1 and 4. Oops, excuse me. That's going to happen at pi over 3. Or 5 pi over 3. Pi over 3 plus 2 pi n. 5 pi over 3 plus 2 pi n. Tangent equals -1 for my pi over 4 angle, but in quadrants 2 and 4. So x equals 3 pi over 4 plus pi n. And now, or negative pi over 4 plus pi n is what I can do there. And since I did some pre-thinking here because I wanted my solutions on 0 to 2 pi, so I get to write x is equal to, from the first one I have two solutions, pi over 3 and 5 pi over 3. From my second one, I can see I have two solutions from 0 to 2 pi. That's going to be at 3 pi over 4 and negative pi over 4, but I can't say negative pi over 4, so I add 2 pi, which is 7 pi over 4. And those are my solutions to number 2. That should be fairly straightforward based on the identities that we already know. So now, ooh, whoa, fun stuff. If we look at the next set of questions, it says if the angles are not the same, try an identity to get the same angle throughout the equation, solve over 0 to 2 pi. So now we got to look for things with this extra layer of complexity, maybe a double angle or a half angle. So hopefully when you look at number 3, you can quickly identify that, ooh, look at that. Cosine of 2x is a double angle. I can substitute in for that one. Now I have a few options for cosine of 2x. Notice I already have a sine x in this equation, so I want to use the double angle identity that also only has sine x. So I'm going to go 1 minus parentheses, because cosine of 2x is 1 minus 2 sine squared x minus sine x equals 0. So hopefully you can see I have substituted in, wow, that's my new favorite pen, that one right there as my double angle identity. So now I distribute the negative sign, write it in a way that makes sense to me. So 2 sine squared x minus sine x. And you'll notice the ones are going to cancel out right there when you redistribute it. So after one step, I am down to just this. I can now factor out a sine x. Left with 2 sine x minus 1. So once again, I have either the first thing is equal to 0 or the second thing is equal to 0. I do my little unit axes. Sine of 0 happens there, or x equaling n pi. Sine x equaling positive 1/2 happens at pi over 6 and 5 pi over 6, since it's positive in quadrants 1 and 2. So this is pi over 6 plus 2 pi n and 5 pi over 6 plus 2 pi n. Again, be aware of the directions. This says solve over 0 to 2 pi. So I'm going to make sure that my final answer, ooh, that got thicker, is 0 pi. And since it's inclusive 0 to 2 pi, I would also include the solution 2 pi, even though it is coterminal with 0. And for my other problem, I have pi over 6 and 5 pi over 6. So for this particular problem, I have 5 solutions. All right, let's take a look at number 4. This one is interesting because I have a tangent x and a sine of 2x. Now these are going to take some getting used to, right? The quicker you know your identities, the faster you know your identities, the quicker these will come to you, and you'll be able to kind of see the patterns and see which ones are going to be most helpful to you in different situations. But I have tangent x. I'm just going to leave my tangent x. I only have one double angle for sine, so I'm just going to try plugging that in and see where I can go from there. Okay, so I've got 4 tangent x plus 2 sine x cosine x equals 0. Nothing I can pull out so far, so I might change my tangent into sines and cosines. So if I do that, it's a little bit harder to write on my iPad, I apologize guys. Sine x over cosine x plus 2 sine x cosine x equals 0. And maybe I want to get rid of the denominators, right? So maybe I multiply by cosine on both sides. Maybe I multiply by cosine x. And maybe I also just divide everything by 2 since both terms are divisible by 2 anyway. Don't have to, but you can. So that I'm left with 2 sine x plus sine x cosine squared x. And now this becomes a familiar scene. I can factor out a sine x, and I can get 2 plus cosine squared x equals 0 by my ZPP, either sine x equals 0 or cosine squared x equals -2. On my unit circle, sine x equals 0 there or there, x equaling n pi. On this side, I would square root both sides. So cosine x equals plus or minus root of -2. And we're taking the root of a negative number, so that has no solution. So my only solutions here are 0, pi, and 2 pi. Lovely. Wonderful, wonderful. All right, so looking elsewhere, hopefully we are getting the hang of things. Maybe I will show one more. Although now I've kind of ran out of room on there. Yeah. All right, so there's really only one place for me to go, right? I have a half angle identity for sine. So I'm going to start by plugging that one in there, which is one of the weird ones. Plus or minus the square root of 1 minus cosine x over 2 equals 1 minus cosine x. I'm solving for x, so typically I see x's on both sides. If this was an algebra problem, I would square both sides, right, to get rid of that square root. So I'm going to do the same thing here. I'm going to square this side and square this side, which is nice because then that gets rid of that plus or minus for me. Don't have to worry about it anymore since a positive or a negative number squared is still positive. So this becomes 1 minus cosine x over 2 is equal to, now on the right hand side, you can't forget to FOIL. So we've got 1 minus 2 cosine x plus cosine squared x. Oh, looks just lovely, just lovely. We're going to want to multiply the 2 on both sides. So I'm going to left 1 minus cosine x is equal to 2 minus 4 cosine x plus 2 cosine squared x. And at this point, this should be looking familiar. You should be more comfortable at this point getting everything to one side, factoring it, and using your ZPP from there. So I'm not going to finish that one. Go ahead and pause the video and finish that one on your own if you need. Well, pause the video and finish the problem and then check the answers online if you need. And then for 6, 7, and 8, does the equation fit the pattern of one of the trig identities, or can you transform it into a different trig function? Solve over the interval 0 to 2 pi. So for this one, you are looking for special cases or simplifying a little bit and then looking for special cases. So if I notice, this first one is sine of 2 theta cosine minus cosine of 2t sine. So if you remember, that looks like my sum or difference identity for sine, if you remember. So the easier way to do this one is to identify that that is a, see if I can write it. Let's do a color. Let's do a pretty color. Yay. This is going to be my difference identity for sine. Yay! And since it's my difference identity for sine, I should be able to simplify this in one step. This should be sine of 2t minus t equals 1, which means sine of 2t minus t is just t equals 1. I think about my unit circle. Sine of t equaling 1 happens only up there. So t is equal to pi over 2 plus 2 pi n. Oops, so sorry. Right, sine of 2t minus t. Yes, yes. So pi over 2 plus 2 pi n. There is only one solution on the interval 0 to 2 pi, which is pi over 2. So take a moment, try 7 and 8 on your own. Look for identities first. Side note, you might have to FOIL or plug in first, and then try something on your own. Check the key when you are done.